Here we have section 9.6, solving rational equations. There's two kind of approaches that we take with solving rational equations, and it really depends on what the rational equation looks like, because sometimes you'll end up with one fraction on each side, which means that we can just cross multiply, which is something that we end up doing pretty early on in our math career. So cross multiplying should seem familiar. If there's not just one rational expression on each side, if there are a total of 3 or more in our equation, we're going to have to use a least common denominator. So the simpler thing is cross multiplying, because we start off with something simpler. When we cross multiply, you often will see people circle to where it looks like an X. This is cross multiplying. It gives you a resulting equation that's no longer a fraction, and so then you solve that equation however you need to. Either it's a linear or a quadratic equation most of the time. So you solve that, and then you have to go back and check your answers to see if you have any extraneous solutions. If it's the more complicated case of least common denominator, it's kind of like we're pretending to add all of our fractions together. We want to come up with that least common denominator, but when we multiply everything by our least common denominator, we actually get rid of our denominators. And so again, we end up with an equation that doesn't have any fractions. Again, we have to check for extraneous solutions. We've had extraneous solutions before, and so remember that they are caused by our method having a flaw inherent in the way we solve them, that we just, because of what we're doing, because we're dropping the denominators here, we have to check to make sure that we haven't come up with something that actually would be a problem, which in this case is anything that would make our fraction have a 0 in the denominator. So hopefully we'll see that happen on one of our examples so that you can see exactly what I mean. So these first few are solving by using the LCD. So what we want to do is we want to figure out what would I multiply this equation by that would cancel out all 3 of these denominators. The best answer to that is the least common denominator. So of x, 4, and 2, we know we need an x, and we know we need a 4. We don't also need a 2 on top of that 4, because 2 times 2 is 4. Like, that's inside, this 2 is inside of this 4x. What we're going to do is we're going to multiply each of these by 4x over 1. Now I'm going to write it out on this one to make sure that we understand what's going on. You do not have to write it out every single time, but here's what we're doing. We're putting this 4x over 1 with all 3 of these fractions. And then we are going to cancel out things in the numerator and the denominator that are in common. So this x and this x. That means what I have left is 4 times 12, which is 48. I can cancel this 4 and this 4, so that now I have x times 3 is 3x. Here I can cancel this 4 and this 2. And so I have 2x times 3, which is 6x. Now, this is a linear equation that we can solve, hopefully pretty easily. (48) divided by 3 is 16. So our supposed answer right now is x equals 16. When we go back to check for extraneous solutions, all we're really needing to do is say, if I put a 16 right here, does it give me a 0 on the bottom of my fraction? Well, of course not. It gives me a 16. So since it didn't give me 0 on bottom, this must be a real solution instead of an extraneous solution. On example 2 here, we still have 3 different things. Even though one of them is not a fraction, we're going to write it over 1 so that it will be. And so we cannot cross multiply here. We have to use the least common denominator. In this case, our least common denominator would be 8, because I can turn 8, 1, and 2. All of them can turn into 8. If you want to write out 8 over 1 the 3 different times and cancel, you can. Or if you can think in your head, okay, I can cancel these 8s and it leaves me with x squared. I don't cancel anything on the second one, so when I times this by 8 over 1, it gives me 32 over 1, or just 32. This last one, 8 and 2 cancel and leave me with 4 on top, so I get 4x. So I'm just distributing this to everything in my equation, canceling out as I go along. So I guess another way to write that in between step is to write something like this, and then to cancel that cancels, this cancels. If that helps, then do that. All right, we have a quadratic equation here, so we want to get everything on one side, and hopefully we'll be able to factor, but if not, we can always use the quadratic formula. You might say that we'll go and get our factoring shoes and put them on wherever they may be. Looks like we've got -8 and +4, and so our answers are 8 and -4. Now, when I go back to check my answers here, or maybe you noticed at the beginning, if I don't have any x's in my denominator, then there's not any way for me to get an extraneous solution. So both of these are actually answers, because when we go back and plug them in, there's nothing that would cause them to make a 0 on bottom, because we can't get 0 on bottom for anything. So 8 and -4 are answers. And this one's a little bit more complicated, even just by looking at it. So we've got x plus 2 and x minus 2 and x squared minus 4 as our denominators. Hopefully we would recognize that x plus 2 and x minus 2 multiply to get x squared minus 4. So our common denominator is x plus 2, x minus 2. And we don't need to also multiply that by x squared minus 4, because these actually are the exact same. Those would cancel each other out. I apparently can't just get rid of that, so there we go. So those cancel on that first one, which is nice. And then it's helpful to write it out like this so that we can see exactly what cancels on the other two fractions. So it cancels this out entirely and leaves us with x minus 1. The x plus 2's would cancel. So x plus 2 and x plus 2, leaving me with 2 times x minus 2. And then on the second or third, the third, x minus 2 and x minus 2 cancel, leaving me with 4 times x plus 2. So we want to distribute for both of these. We've got a lot of x's here, so 6x plus 4, subtract my 6x, add 1, which is 5, divide by -5, get x equals -1. When I go back and plug this in, it does not give me 0 on bottom. -1 plus 2, for instance, gives me a 1. -1 minus 2 gives me -3. -1 squared minus 4 is -3. So it does not give me an extraneous solution, it is an actual solution. These last two are cross-multiplying, so we have not had an extraneous solution happen to us, which means I don't think we're going to. So just keep a lookout as you're working through your assignment to see if you can notice a time where something would be extraneous. Alright, so we're cross-multiplying, so we're going to do x times 8x equals 4 times 2. So 8x squared equals 8. This is a pretty easy equation to solve since there's not an extra x term. We can just solve for x squared, and then square root both sides. Remember that we have two answers because it's a quadratic equation, and so it's positive and negative 1. When I plug those back in right here for this x, I would get a positive 8 and a negative 8, and that's not 0, so both of these are answers to our equation. That was pretty simple. It can get more complicated with cross multiplying, although it shouldn't be that complicated. I mean, I guess they could give us some really complicated fractions, but we just need to cross multiply. So distribute 7r minus 35 and 6r plus 12. So subtract 6r, add 35, add 35. So r equals 47. That's a really large number, and it does not give us a 0 on either side, so that's handy. And that's our answer, r equals 47. I was just trying to check it in my head real quick because it was such a big number. All of these examples actually worked out to be really nice numbers. That's not always the case, especially with rational expressions. Fractions are very common as answers. Also, we didn't end up with an extraneous solution, but that does not mean that you wouldn't end up with one on whatever your assignment is. They sneak up on you. Most of them won't probably be extraneous solutions, but you will have the occasional one. So, good luck.